Okay, so great students, I welcome you once again to yet another concepts on functions. So this one we are going to look at how we can find the zeros or the roots of a function. Previously we have already talked about the range of a function, domain, inverse of a function. We are now looking at zero. So when we see zeros of a function, what are we looking at? In this case, we are saying that the zeros or the roots of a function, say f at x, are the values of x for which f at x is equal to 0. So it means that when you are asked to find the zeros or the roots, whatever values you get for x, if you substitute those values into the actual functions given in the question, you are going to get what? 0. So that is what we mean by what? The zeros or the roots of a function. Okay, so when the question is given to you, so this one is very easy. All that you need to do is just equate the function to 0 and solve for your unknown variable. All right, so we'll not waste time. Let's take the following examples and look at how we can find those zeros of these functions. Okay, so for example 1, okay, let me start with our solution. So for 1, now this is what is given. I can also rewrite it as f at x is equal to 3x minus 4. So when we say find the zeros, okay, all that you need to do is just equate the function to 0. That is, for zeros of a function, it means f at x is equal to 0. Then you solve for your values of x. Okay, all right, so I will just write 3x minus 4 is equal to 0. Then solve for x, and this gives me, if I should transpose this one, then I'll have my 4 here. Then I can divide both sides by 3. Okay, good. So my x is equal to 4 on 3. Good. So it means that the 0 of this function is what? 4 on 3. That means if I should substitute this here, I'm going to get 0. That is what we are saying. So let's test and see if it indeed the function, when we substitute, it will be 0. It will go 0. So it means that I'm going to write f at 4 on 3, which will give me 3 multiplying 4 on 3 minus 4. Now we know that this is 3, so I can cross this 3 out, leaving 4 minus 4, and that gives me what? 0. So it is true that the 0 of this function is what? 4 on 3. So that is the meaning. Okay, now let's look at example 2. Let's look at example 2. So for example 2, I have j at x. I have j at x is equal to 4 minus x squared divided by 2x plus 1. Good. Now, since we are saying for the zeros, we should just equate the whole function to 0 and solve. Then I'm going to write 4 minus x squared divided by 2x plus 1. All should be equal to 0. Okay. Now, since we have this denominator here, we can multiply both sides by the denominator. All right, good. So if I'm going to multiply that, then it means that when I multiply that, here will cancel. So I will have 4 minus x squared is equal to 0 multiplying what? 2x plus 1. Okay, yes. I just want you to understand. That's why I'm writing the 0. It means that when 0 multiplies this, the entire expression will still be what? 0. So there are times that we don't even worry ourselves to write 0 times this because it still gives you 0. But I just want you to understand the concept. Okay, so I will just write my 4 minus x squared, which is equal to 0. Alright, because when you multiply all this by that, you are getting 0. Now, once we have this, we can rewrite it as 2 so that I can use difference of 2 squares. Okay, good. Then I have can have 2 minus x or 2 plus x, which is equal to 0. Okay, so I'm going to continue from here. Now I'll have 2 minus x is equal to 0 or 2 plus x is equal to 0. So if that's the case, then I can see that my x is equal to 2 or x is equal to negative 2. Okay, great. So it means that these are my zeros of that function. My zeros are 2 and what? Negative or 2 or negative what? 2. It means when I substitute any of these values, am I going to get 0? That is what we are trying to say. Yes, if I substitute any of this, I should get 0 for the whole what? Function. So that is, this ones is not anything difficult. Okay, all right, we have been solving some of these examples. So all that you need to understand is that when we talk of the zeros or the roots, there are times that we may not say find the zeros, we may say find the roots of the following functions. And when we say find the roots, we mean the same thing. You are going to equate to 0 and solve. Okay, all right, so let's look at the third example. So for the third example, we have h at x is equal to square root of x squared minus 25 all divided by 3x squared plus 5x plus 2. Good. So this one too, we are going to equate everything to 0. Then I'm going to write square root of x squared minus 25 all divided by 3x squared plus 5x plus 2 all equals 0. And you know that we are going to, because this is the denominator, we are going to multiply by 0. So again, we are going to have x squared minus 25 equals 0 multiplying what? 3x squared plus 5x plus 2. And that gives me x squared minus 25 equals what? So everything here will be what? 0. Now since we have square root here, we can square both sides. So it means we can square here and square here. So that means I can square this x squared minus 25 all squared and square what? 0 as well, which 0 squared is still what? 0. Okay, so that this one will go. Then I have x squared minus 25, which is equal to 0. Okay, good. So once I have this, then this one to difference of 2 squares will work for me. Then I can write x squared minus 5 squared, which is equal to 0. And then I can have x minus 5 and x plus 5 is equal to 0. So this is what I'm going to solve. Okay, I'm going to continue down here. So from here, yes, so I'm continuing from here. Now it means I'm going to have x minus 5 is equal to 0, or x plus 5 is equal to 0. Okay, great. Then I have x is equal to 5, or x is equal to negative 5. So it means that these are also my zeros of that function. It means when I substitute any of these values there, I must get what? 0. So that is what we are talking about. Okay, so for zeros or root of a function, it's not difficult, very basic. Okay, all right, so let's end here and continue next time. But in our next video, we are going to look at the values that will make what? A function undefined. Yes, when we are given a function, you see that we have already looked at situations or values that will make a function defined, and that is what we did as what? The domain, finding the domain or the range. Okay, finding the domain or the range, especially the domain. When you are asked to find values that make what? A function defined, and we are looking at the domain. But this time in our next video, we are going to look at values that make what? Functions undefined. Okay, all right, so see you in our next video. Bye bye.